Okay, let's go ahead and start with chapter 3, section 2, which covers solving equations in basically a multiplication form where it's ax equals c. Hopefully you can see that at the top of the page right here. Ax is in c. So we have a little bit of note, a little note here that we have to make on multiplication equations. And Uh, this is a real simple note, and I don't think a lot of people like if I said, "Hey, demonstrate this." A lot of people couldn't do it, but I mean, a lot of you probably are very familiar with it. You're probably just not familiar with the name of it. However, let's go ahead and go through it. Multiplication equations are solved. Sorry, I have to fix that. Multiplication equations are solved using what we call the multiplicative inverse. That's what it's called, multiplicative inverse. All right, fill each blank with a number that gives you the desired result. So in all these examples, A through D, we want to use the multiplicative inverse so that we end up with basically every one of them is x. So we want to get x every time. So so the multiplicative inverse of 6x would be 6. Okay, and it's easy to demonstrate that because the 6's cancel, right? And that's kind of the point of the multiplicative inverse. I know I crossed it off, but really, I mean, they cancel, but when you think about it, 6 divided by 6, what is that? That is, well, anything divided by itself is 1. And that's the intended objective of multiplying something by the multiplicative inverse, which is we want to get 1. That's our goal. All right, so a lot of times we just say these cancel, but they're really turning into ones. All right, and so notice how all that's left there was an x. See that? So all right, and so on B right here, what do we do so that we're just left with x? Well, the thing that we have to divide by is -2. See, -2 divided by itself is 1, right? You get 1x, right? 1x is the same thing as just x. All right, the multiplicative inverse of this one is going to be, you probably guessed, 5, right? Those cancel. You're left with x. Right here, the multiplicative inverse of example D is -7. Okay, so it's a pretty simple concept, isn't it? It's not that difficult. Okay, now let's use the multiplicative inverse to get these. So you got 5n equals 20. All right, so the multiplicative inverse of 5 is going to be multiplying by, I don't know, let me use the right color, it's going to be 1/5, right? We're going to multiply by 1/5, like that. So we're multiplying by that, all right? Those cancel, right? Because 5 divided by, or 5 times 1/5, or 5 divided by 5, in other words, is 1, right? That's what you get. And then on the other side, we're left with basically 20 over 5, right? That's what's, and then 20 over 5 really means 20 divided by 5. 20 divided by 5 is 4. Okay? And so when you're doing the multiplicative inverse, you're probably more familiar with it kind of being demonstrated like this, where you just kind of divide that number. But if you're really going to be technical about it, we're really multiplying by 1/2, right? That's really what's going on there. Multiplying something by 1/2 is the same thing as dividing by 2, right? That's, multiplying by 1/3 is the same thing as dividing by 3. Kind of get that connection? You're probably familiar with that. And -16 divided by 2 is -8. Okay, and that's the answer. So x equals, that's the solution to x at least. X equals -8. Right here. Oh, I should also remind you that, when you're looking for the multiplicative inverse, look at the variable side. Look where the letter is, and that's what you're going to be able to kind of figure out. Well, we're gonna divide by 6. We're not dividing by 18. We're divided by 6. So, and those cancel. You got -18 divided by 6, which is -3. So you got C equals -3. All right. on here. Now this one, we could take a couple different approaches with this. I mean, we could just do 6 times 2m, right? 6 times 2m. Let's do this a couple different ways. Is 12m. So I'm going to rewrite this as 12m equals 36, and then do the multiplicative inverse of 12m, which is going to be times 1/12, or in other words, divide by 12. Divide by 12, and you get m equals 3. All right, another way we could do this, let me just kind of rewrite it. Another way we could do this is we could just go ahead and just do the multiplicative inverse of 2, or we can do the multiplicative inverse of 6. We could do that. We can just divide by 6 right away. Do that. That in turn cancels off the 6, or in other words, they turn into 1s, you know? And then now you got 2m equals, and then 36 divided by 6 is 6, right? 36 divided by 6 is 6, and then divide by the multiplicative, or multiply by the multiplicative inverse of 2, which is divided by 2, and then you get m equals 3. Yeah, same thing, right? So a couple different ways you can do it, and same result, same thing. All right. For this one, I would definitely like clean it up a little bit. I mean, it's got a lot going on there, but like we can definitely turn that other side into 32, right? We can turn that into 32. So I'm going to rewrite it. So you got 2, and then t minus 4 equals 32. You also might recall, like, with order of operations, that parentheses come first. However, when you're doing inverse operations, parentheses don't necessarily have to come first, because everything's getting undone. Everything's being done in opposite order, much like the way you put on your socks and your shoes. You put on your socks, then your shoes, but when you're undoing all that, you don't do it in the same order. You take off your shoes, then your socks. All right, that's kind of what happens with inverse operations. Everything gets turned around. It's all topsy-turvy. So what we could do right here is we could just divide by 2, right? We can divide by 2, or in other words, multiply by 1/2, right? Those get canceled. We'll write it over here. You got t minus 4 equals, and then 32 divided by 2 is 16. All right, and then just add 4 to both sides. And there's more than one way to do that, but I think it's okay if we just kind of stop with that one. That way, oops, I almost about to write 4. 16 plus 4 is 20. I was about to divide. All right, so you got t equals 20.